True, false. The kernel of a linear transformation is a vector space. Yeah, that's true. This is just the name for null space. Okay, when we are talking about a matrix, we call null space. But when we talk about linear transformation, the same null space is called kernel. I mean, they are almost the same. In fact, the same, but we call differently in different contexts. Column A is the set of all vectors that can be written as AX for some X. Yeah, for some X. That's the definition, exactly the definition. Okay, that's the definition of column A. And let me write here, column of a matrix A is, okay, just some B such that AX equals B for some X. In fact, if we talk about a matrix mapping A which has size m by n, this is Rm, this is Rn, so this B is in Rm and X is in Rn. Okay, so that's true, that's the definition. Null space is a vector space. Yeah, that's true. That's by null space, everything in here that are mapped to 0 vector in Rm. So it's a vector space. True, by definition. I mean, or we can show those three properties, by the way. The column space of an m by n matrix is in Rm. Yeah, column space lives here, null space lives here. This is true. Column A is the set of all solutions of Ax equals B. Look at that, for some X, not for all solutions. So this is false, because the definition is column A is just B in Rm that are mapped by A, that are mapping of X. Okay, X is mapping to this one, and this is called B. Not for all X, for some X. So this is false. Look at this, for some. It does not say, it says all solution. That's false. Null A is a kernel of the mapping. Yeah, when we write in these terms of mapping A in terms of matrix, then we call null A. And if you look at here, when we talk about linear transformation, the same null space is kernel, just a different name, and that's true. It's the kernel or null A, about the same, just the different names, because it involves a mapping with matrix. And if we say linear transformation, then we would say kernel for the same thing. The range of a linear transformation is a vector space. Yeah, that's true. By definition, you can show. Because this linear transformation, when we have this, maps 0 to 0, 0 vector to 0 vector, and all others. So that's true. The whole thing is codomain. That is not a vector space, but whatever mapped using these, okay, and that could be everything, maybe subset. Yeah, this is a vector space. True.